All right, so this next section, I'm just going to talk about the actual NSX components, the actual pieces that go into it. We may do it quickly. I think I've described a lot of them already along the way. So with the NSX for vSphere components, so we'll start at the top and work our way down here. So at the top, we've got this cloud management portal. No, not really a part of NSX, but let's say NSX, it's valuable, it's useful all by itself. It works well. All the firewall, all the routing, all that stuff you can configure it just within the vSphere client. That's the graphical interface for it. You can configure it programmatically. You know, it uses REST APIs, it uses the like. It really shines when it's tied into a cloud management portal. Automation Center from VMware is the one we're most familiar with here. But it really shines in that case. So the NSX product has a management plane, has a control plane, and has a data plane. So at the management plane, we have the NSX manager. The NSX manager's got a one-to-one relationship with the vCenter server. Okay. They mentioned that message bus agent. That's part of what's in the ESX host, so they can communicate with the manager. The control plane, we've got the NSX controller cluster. It's three virtual machines, 3 virtual appliances. It's always 3. They use, normal current big data, distributed execution kind of models in this. Those 3 together work collectively to program the ESX high hosts, program those modules in the hosts about what the configuration is for the tunnel endpoints, what the configuration is for the router, what the configuration is. It's actually what's keeping track of what the MAC addresses are, what the ARP tables are, and distributes that to the ESX hosts. Then if I've got distributed logical router and I go to deploy it, I've got a choice. I can deploy it with a control VM or I can deploy it without a control VM. Typically we deploy it with a control VM. And the reason we have that control VM is because routers like to talk to other routers, not a bunch of other routers, one other router, right? They form, they get these adjacencies, they have peers. So what happens in this case, the distributed logical router control VM is what actually does the peering with your other routers. It then programs the distributed logical router on the ESX host through the NSX controller cluster as far as what routes, what's available on those different ESX hosts. The actual data plane is mentioned already, the distributed virtual switch, and then when we've deployed NSX in the environment, we've prepared the hosts, then you see we've got the modules for the VXLAN, for the distributed router, and for the firewall. Okay. So basically, the main components that are there. Now, there is also an edge services gateway. It's actually a virtual appliance. It's a router. That router also can provide a lot of services. How many of you are familiar with vShield? vShield Edge. This edge services gateway is a descendant of that vShield Edge. Okay, so do DHCP, it can do NAT, it can do all the things that it could do there. Now it's under the control of ESX, or excuse me, NSX. That button. All right, so the NSX manager mentioned already, one-to-one mapping. It provides that management interface, uses the web client plugin, installs the modules. The controllers mentioned already, they're clustered for high availability. It's 3, it's always 3, it's only 3. A design consideration, this is on a later slide, but from VMware, the recommendation would be we have a management cluster where my vCenter, NSX manager, maybe update manager, other pieces, the VMware stack, right? So log insight might go in there, vRealize operations, all those things that would go there. They're not really the workloads that your business customers are putting in your environment. They're there for managing and administering and monitoring the environment. So typically at this point we have a pattern where we have a management cluster where we concentrate those things. Then we have compute clusters or multiple compute clusters, and that's really where the workloads are. We call those workload clusters, resource clusters, whatever it is. With NSX, they make a recommendation that you have an edge cluster or an NSX cluster. And on that NSX cluster, we would put the edge services gateways, if we have any of those. We'd put the controller VMs for the distributed logical routers. Some cases, if the management cluster didn't have enough resources, you could put the controllers on that edge cluster. The thing they want you to pay attention to there's going to be 3 controllers. There's always going to be 3 controllers. There'll never be less than 3. There'll never be more than 3 if you follow actually, it could be less if you just didn't deploy them all. But you're not going to get to 5. And they should be on individual ESX hosts. We don't want to just have a 2-node cluster and lose 2/3 of those controllers because we lost a single host. So make sure it's a 3-node cluster. And I wouldn't recommend anybody do a 2-node cluster anyway. Do a 3-node cluster, just makes your life better. All right, so I already mentioned that network information that's sliced. That's a technical term, right? That's how it decides which controller is going to be taking care of which parts of the environment, and that's how they also divvy up which ESX host they're going to be communicating with to manage that environment. The controllers, here we go. An example again, they keep track of the mundane things that are critical for our network environment. The user world agent, I mentioned this already. This is that allows the NSX host to communicate, or the ESX host to communicate with the manager. Runs as a service. It logs to this net CPA log. Okay. This shows some of that interaction. So here's the VXLAN module, the logical router module, the controllers. So the controllers are in communication with the NSX manager. They're also in control. They're also in communication with the user world agent. That's that control panel agent. Okay. Trying to get to the demo so you can actually see it work. I mentioned the virtual switch already. Talked about the NSX edge. I went to change the slide, so it didn't say edge logical router. It said distributed logical router. I left it because in the actual interface, it's kind of annoying. But when you go to deploy a distributed logical router in your environment, it asks you, do you want to deploy an edge? And that edge is the control VM, not the edge services gateway. It's just unfortunate reuse of the term. So in any case, that's the components there. Again, the NSX virtual switch is your VMware distributed switch with the kernel modules on the host. Okay. Now, the actual deployment, pretty straightforward. So the one-time stuff, deploy the NSX manager. Next, deploy the controller cluster. Now, if I'm thinking about this and I've got an existing environment and I'm interested in NSX, and I'm really interested in the use case for the micro-segmentation and I'm not so much concerned with the logical switching and the like, you don't have to deploy the controller cluster. You could just go right on to preparing the hosts. And that's what makes the distributed firewall available. And then if later you wanted to add in the logical switches, the encapsulation, then you could deploy the controller cluster, because we need to have that controller cluster in order for that to operate. And the logical network preparation, there is some things we do here. Since it's automated, we set up a pool of segment IDs. So when you tell it to make a new logical switch, it assigns it a segment ID automatically. That segment ID doesn't translate to any kind of a VXLAN, but it is the logical switch ID that NSX uses to keep track. It's the VXLAN segment ID. All right. Then on the recurring, so I want to deploy a new application. I'll go ahead and deploy the logical switches per tier. Deploy the distributed logical router or connect to an existing one. Create a bridge network. I didn't go into here, but we can do bridging, right, between the VXLAN and the VLANs. That bridging is done on the host where the distributed logical router control VM sits. Okay. And then connect to a centralized router, right, so we get access to the external networks. So the requirements, mentioned these already. Well-maintained, reliable infrastructure. That's the key, right? It's always been the key, but that's definitely the key here. It doesn't have to be fancy, it just needs to be rock solid. You know, but hopefully that resonates anyway. Nothing special here. For Greenfield, that spine leaf architecture or some other kind of a fabric architecture that gives you that connectivity. For VXLAN, remember there's a requirement because we're doing that encapsulation. We have to have the MTU on the underlay network needs to be set to a higher number. I don't know if you set it to 16 or 1650. Probably a lot of you already have set jumbo frames to some much larger number anyway. The key here is like everything else, make sure it happens end to end along the whole path. Have to have the distributed virtual switch. Deployment considerations, I already talked about the management cluster. So again, the 3-node controller cluster, those really should be on individual hosts. So 3 nodes for the cluster. The compute cluster, take your existing clusters. We would just prepare them with the NSX manager. The edge cluster, now, the edge cluster has if we concentrate our edge services gateways in this edge cluster, and if we concentrate the distributed logical router control VMs in here, these hosts are the hosts that are going to have access to external networks. None of my compute hosts have to have any access to the external networks, right? They don't need to go to the internet. They don't need to go to other places. So it's another way I can improve my security by making sure that I can't even get off of these hosts onto those external networks without going through the routers, the distributed routers and like, because we haven't even cabled it into there, right? So only provide those to the edge cluster. Integrations. We'll have a better example of this actually in the demo that they're going to show. They'll definitely show the integrations a lot. The way VMware has built this in, the integrations, the way they're configured through the plugin in NSX Manager. And the way VMware has this, there's this services pipeline that's part of the virtual NIC on the virtual machine. And it's set up with different slots. Not that you care. Slot number 2 is always a distributed firewall. Then the partner services come on the slots after that. So slot number 4, I think in water, slot number 4 probably is the Palo Alto network. So we can go ahead and do redirection out to a Palo Alto virtual firewall for deeper inspection on things that are interesting to us. How we determine that. So you make the security policy for the distributed firewall, you specify the action as a redirect to Palo Alto, and then it uses whatever has been configured in the Palo Alto networks environment for that. Similarly for Trend Micro, if you're familiar with deep security from Trend Micro, this integration with NSX is again in that service chaining. So it gets access to the traffic coming in and out of the machines, that's being redirected out to the machine, out to the Deep Security Manager, actually to the Deep Security virtual appliances to actually do the scanning. So, the water guys. So I'll pass it off to Chris Binger and Reza.
Hi, I'm Chris Binger and Reza, and there's a guy who's not here today, Joel Rich, and Dennis. We were the ones who worked on this project for DWR and to set up the next generation data center. And I just wanted to be sure that Joel and Reza get some credit because they definitely did a lot to get us here. Okay, so I'm just gonna go quickly through here so we have time for the demo, just to show you what we're gonna demo. So basically we're gonna put up a 3-tier stack and one of the web servers is gonna be provisioned behind the F5. This is basically what our automation does when we go through this. We can do an N-tier stack, we put it up on the F5, we deploy applications like Microsoft SQL, fully installed, ready to go with user accounts built in it, and the Commvault client and the Trend clients on your VMs right when they're deployed before you even start to use them. And then when we decommission, we automate the cleanup of all the stuff that happens, like when it gets added to AD and DNS. So there's no orphaned objects. Whenever we do this, everything that happens when we provision gets unprovisioned when they get decommissioned. So what we're going to do right now is we're going to build up a Windows box with SQL 2012 on it, and it will also have the Commvault client and a few other things. The Linux VMs will be a 3-tier environment, and there'll be one web app and database. They're all going to end up in the appropriate security tiers. They're going to be dynamically added to the NSX security and the Palo Alto security zones, all through dynamic updates. And they will be immediately protected by the correct firewall policies as soon as they're done. And they'll also be anti-malware protected by trend. So when we do it behind the F5, the VMs that are going to be behind the reverse proxy are going to have 2 NICs assigned to them. One has a private network just to the F5, and then the other one is the one you manage your normal web server through like you always do. And then we'll also create a virtual server up on the F5, its pool, and it will put the right SSL cert policies on the server by its name. It will give it the right cert. And your default web page will be available immediately upon provisioning. And so this is the stuff I just explained is going to happen. And this is a basic representation of our network. So we're going to have these different tiers. We have the web tier, we have the app tier, we have the database tier, we have our infrastructure tier, and then what's that?
I can't see a point.
I know, I was hoping this thing would have like a mouse that would hover over something, but it's not doing it. And so when it leaves the chassis, then we go up to our Brocade fabric where we have 4 Brocade switches in our fabric. The F5's plugged into there, and then that's plugged into our Palo Alto, physical Palo Alto that does our north-south firewalling. This is our firewall posture, and this is what you guys should remember when I'm going through the demo, is what can talk to what. We have multiple tenants in our environment, so no tenants can talk to each other. So this is the 2 different tenants. The presentation tier can only talk to the app tier. The app tier can talk to database tier or the presentation tier, but there's no jumping tiers. Database can't talk to presentation, presentation can't talk to database. Everything can talk to your infrastructure tier because that's your AD, DNS, and time servers.
And what about within the tiers?
Within the tiers, there's micro-segmentation. You cannot talk amongst the tiers. So everything in your web tiers web servers can't talk to each other, app servers can't talk to each other, and database servers can't talk to each other. So we're just going to go over real quickly the hardware components we use to support this. Is we use the Brocade 6740s. We have our HP C7000 chassis with 460 Gen 8 blades. We use Pure Storage. That's all flash storage arrays for our VDMKs, and anything that's a network file system, we use NetApp for our NASs. And then we have the Brocade DCX on our for our fiber connects. And we have Palo Alto 5060 firewalls and the F5 VIPRIN 2400 chassis. The software we use to make all this work is vSphere 6.0, and you can see all the different vendors we use. All these vendors have been partners with us and have really helped us get to this point because they gave us developers to work with to help write scripts to integrate all this. So we have a real complete package because of these vendors, and they are our partners. So it was really, that's why we wanted to list them here so everyone can see who we worked with. When we're done, when we decommission, we're going to back out everything that we added in here, and we'll show you that at the end. And normally we have questions, but we have to hurry. So I'm going to get to the video right now. So basically, right now, this is our portal. Okay, so this will be your home page. And then this was the catalog that you just saw that I can't get this thing to stop at. We'll see the catalog more in the future, but basically what you see at the catalog is all your blueprints that you have to choose from. First one we're going to do is a SQL server. And the SQL server takes quite a while to load because you got to install SQL, you got to configure SQL and add all the user accounts. So we're going to start that first. And I'm going to kick out the dead space. So here's the catalog right here of all the items you can take. So when you go in here, I'm going to put more RAM. By default, I have 2 CPUs. We're putting 4. And I'm going to add up the memory up to 24 gigs. And so when you get to this, you just customize your machine as you see fit by going through the different pages here. The next one here shows all the different drives. If you need to make your drives bigger, you make them bigger there. These are all our custom properties right here. This is pretty important. This is what makes the automation work, is these are a bunch of scripts that are in Orchestrator that VRA calls to and calls these scripts. And then they, when the machine's getting provisioned, it applies all these scripts. So there is batch files it's running, there is JavaScript it's running, there is PowerShell it's running. It's doing a bunch of stuff in the background while these machines are getting provisioned. And so once you do that, you just say, okay, now you're going to get emails to tell you your job kicked off. Then you'll get one when your job's almost done and when it's getting activated, and you'll get one when it's complete. And so you don't have to sit here and do what I'm doing right now as I'm showing you the status of what's going on. This is automatically happening. You see that little thing on the bottom there. So remember, this DB is called DWR-MS-DB 101. I'm showing you that it's not already in an Active Directory, that we didn't pre-plumb all this stuff and just showing you a thing that was already done. This thing is just getting initialized right now, and you can see it's not in our Active Directory. This thing does not exist. And it doesn't exist in vCenter. And we're going to go to a couple more places to show you where things do not exist. We're going to go to, let me see if I'm right. Okay, now we're going to go create 3-tier, and I'll go and show you more stuff on the 3-tier. So this is our orchestrator right here, and to show the job just kicked off. And that 3-tier machine that I built, we have 3 networks. We have 10.158.192, 193, 194 for our 3 tiers. So that's the database tier right there that just kicked off that job. And so I'm showing you the IP address, so later on you can see when we come back to that was the IP address that this machine's going to get, because Orchestrator has a table that it already picked out, the name and the IP. So now in the 3-tier, we're going to kick off, and we're going to try to make 3 machines at the same time. And so first thing we're going to do is give this a security group ID, because if you have multiple web servers or multiple app servers, you're going to want them to talk to each other. Well, with micro-segmentation, they're not going to. So for this app, you would give it a security tag right here that we're giving a name, Merging Tech Demo. Now all these servers will be able to talk to each other through the protocols we allow. And so that's the first step of doing it. Then you go to each machine, you change its utilization. If you want more than 2 CPUs or more than 4 gigs of RAM, you'll do that. And then now when the web server, you got to go and tell it what your public IP address is going to be, what your URL is going to be. And this is stuff that you would do in advance, because you're going to have to get that in DNS for the public to be able to use it. So you're going to know what that is. So we're going to go to the F5 right now to make sure I grab an IP that I know is next in the table. So 10 was the highest number. I'm going to add 11 on here now. And so now this is going to be the public IP that the public gets to. Our other scripts are going to put the 2 internal IPs, the IP for the private F5 interface and the IP for the host itself. So right now then, to show you that this doesn't exist and it's already not a web server, I'm going to go to a URL and put this up here and show that it's going to time out. And all these things that I'm showing you that don't work, we're going to leave the windows open, and we'll just come back later. We'll hit refresh, or we'll hit the up arrow if it's command prompt. So to show I'm not bringing up new windows. These are existing windows we tried from before. This takes about 40 minutes to do this whole presentation live, so I took time out, so this only takes like 23 minutes. So you'll see it jumping a little bit when I've cut out things, but this was the actual step-by-step of what happened. And so now this just kicked off 3 creations of VMs, and it's in one, for a better term, VApp, like they used to call them VApps. Now all 3 of them are under one heading, so I'm going to show you the components now that are the 3 machines. We have our web app and DB server, and so app is 0088. And so now I'm going to show you that they're not in DNS and they're not in AD.
So do you set up templates within VMware so that for you to deploy new servers in the future?
So yes, there's templates and then there's blueprints. Templates are in vCenter
Right.
that you're going to build your machine off of. Then you have your customization specs in vCenter. Those are 2 things you have to have in vCenter. And then in VRA, you have blueprints that are tying a bunch of custom properties to those existing templates. And in VRO, you have a series, we'll get into VRO a lot more later, but you have a series of connections, whether they're REST host connections, APIs into different devices so that you can get all this stuff to work together in your scripts to talk to the right device and then create these up on different devices. So yes, this is the templates now. It's going to clone these templates. Why I'm doing this, it's actually doing that in the background.
You have this menu system that looks a little bit like your DWR website. So this was created with F5?
Okay, so I showed you an F5 screen. I showed you a VRA screen. Right now we're in VRA. Now we're going back to vCenter to show those 3 things don't exist.
Right.
Yeah, part of the deployment is we can brand it, we put logos on it, names on it, so that's why it looks like.
Okay. I'm familiar with vCenter, but I've never seen the menu system.
Yeah.
Like
Okay, so VRA is a portal, and you can customize your portal anything you want. And now this is F5 here to show you that web server did not exist. This is a tool we use for monitoring called Arkin. And Arkin, we're going to show you more later about how it shows all the paths. It knows all about NSX, and it can see inside vCenter and see everything that relates to the VM. And I just want to show you it's not there right now. And then I'm also showing that you cannot ping any of these things. They're not up. You can't SSH any of them. They're not available right now. And so Arkin's done doing that part of the demo. So now this is showing you the progress. So you can sit here and watch your jobs and just watch the progress here. Or this is Orchestrator right here. This is actually all the engine behind all this that's running all this stuff. And so there's 3 stages that you can monitor. There's the building machine, which it's doing right now, which means it's getting the template ready to clone and start putting these properties on it. And then there's the provision stage, which we're waiting for, because the provision stage is the main one, because that's what starts sending all those scripts out to the server so they can kick them off. And it can also send the scripts out to the Active Directory server, make these accounts on Active Directory, make them in DNS, put them on the F5, make the groups in NSX so that they can be dynamically synced up with Palo Alto, so that we have through the whole our whole environment, when a machine's provisioned, it goes every step of the way and it gets populated in every piece that we have. So there was some IP addresses there that were hard to see, but we're going to be going back to them later. And I was showing you the emails that you get that said the job kicked off, that it's going. So here's one of the IPs we're going to be looking for later on the app machine. It's 193.52. That was the first one of those 3 that kicked off. And so now it's showing you it's in a different state now. It's initializing the OS and the software. And so our security groups are that this is throwing them in right now are pre-done. And so we let the web talk to the app server on certain ports. We let the app server talk to the web on 80 and 443. We let the app servers talk on the database ports, but we allow ping to show these tests right now because you wouldn't know that. We'd have to telnet to everything and do a bunch of telnet commands. So, well, right now we're showing you is just with ping, but it's placing these in these security groups. We also have in VRA network profiles that you set up in advance so that you basically have like DHCP set up with these profiles, the address space you want it to use with the network you want to put it on, the NSX network you want to put it on. So when it's grabbing that profile. So right now what's going on, the machine provisioned stage just jumped off, and the stuff you see in the back is the workflow that calls these scripts in the right order and kicks them off. So I wanted you guys to see this because you never see this in these demos, that how much work actually goes in to a machine getting provisioned here. Oh, great. This thing isn't plugged in, by the way. It has 9% left on the battery. So in the background, you'll see up here, these are all the scripts that are running. And so we have sleeps built in so it can pause and everything. Oh, this is not really good at all. I don't think I'm going to make it through the demo.
He's going to find.
Oh, I see what it was. Someone hit the button and turned the power off. All right. So,
You're gonna have to charge him for that.
I know. So now it's running through the scripts. Nothing's like something like that to get you right off target. But you can see some of them have finished. Down here, you can see my email popping up saying that job is finished. When it has a green check mark, it's done. And so this one here is the web server. This takes the longest because it has to put several entries up on Palo Alto because it is a public-facing web server. It has to put stuff up on the F5. It has to specially register in trend since it has multiple NICs. It has to get an Active Directory in DNS. So this job takes the longest, and so there's a big series of scripts that run. And
these scripts are written in what language?
okay, so that's a good question. Okay, so the basic tool uses JavaScript. There's a bunch of default scripts in there that you can use that work for like 60 to 70% of your stuff, but it doesn't work for everything. So we also have a PowerShell server that has PowerShell scripts that this orchestrator calls to that kicks off the correct PowerShell scripts.
So you have a certain number of templates that you can use as the jumping off point and then customize from there. So you're not really starting from scratch then at that point.
No, you have to pre-do, everything here is pre-done, and then you keep recalling the same jobs, but you customize the input. So the name of the server, everything keys off the name of the server. We also use PanPython to work on the Palo Alto. So there's a PanPython server that scripts call to that too. So right now, the jobs are done. I'm showing you, all I'm doing is hitting the up arrow on things that failed before. And now all this stuff is now in Active Directory. This is a Linux server in Active Directory, by the way. And it's in DNS. So it auto-applied on there. I can putty into one of the servers, and now we're going to show you that this is the app server. 193 is the app tier. And so I'm going to do a host name to make sure I'm on the right one. And then we're going to show you I can ping both the web and the database tier. And I can ping them by name to show you that it is in DNS. So first I'm going to show you, though, these are now in vCenter, and I'm showing you the IPs.
Did you statically assign your IP or did you reserve it in DHCP?
That is in the the network profile that we set up in VRA. They get applied that way. See here, right? Let me pause this real quick. So, of course, it went flying right by there. Okay, so right here is the NSX network.
Right.
That your network profile says if you're in the app, profile, you're going to get an address in this address space, the next available. You're going to get put on this network.
So that configuration's done in NSX as an IP range that goes along with that
Okay,
network.
so
So it is statically assigned.
It
It just comes from a pool of addresses that were pre-configured.
Okay, so you're not using DHCP?
No.
Not at all.
Server segment then?
There's no DHCP involved in this. All of this is tied together so you end up in the right security group with the right policies, and it all keys off the name of the server. So our servers are named DWR MS Web. That anything that starts with DWR MS Web is going to be put in the web security container by default, and we'll get those rules, and they can't take it out.
Just, are you using IPv4 for simplicity, or does it do dual stack?
We're using IPv4, but it does work with 6.
Yeah. In fact, that encapsulation, something we skip over the slide, we don't tell you about that stuff. That underlay network could be all IPv4, and you could be using IPv6 with the virtual machines, just as long as you've got a way to get it, translated on the way out, on the way back in.
You can run
Yeah.
And so I'll show you all three that they're landed on the right network. So now this is the DB, and you'll see that it's now in the DB tier and it's on the DB network. And the web has multiple interfaces, so you see it's in 2 networks. And it has 2 IPs because it has the private F5 and it has the web tier. And so now it showed that it finished. And so now all 3 of them are ready to go. And so we are going to go and show you that they showed it dynamically. They got put in the right address groups in Palo Alto without us having to do any hands-on going in. And this is a total different device. And this is Panorama if you're familiar with Palo Alto. And so all 3 showed up in their correct groups on Palo Alto as well. Now when you hit refresh, you'll see that .11 public web address is a virtual server now with the SSL and the AD profile. And I just hit refresh and there's the default web page from Apache.
Is it a self-signed cert?
What we do is we put the cert up on the F5, and then we use a profile that come back to trust the pool member of that virtual server. So that's how we can get away with that. And that meets about, let me hit pause real quick. That hits about 80% of our needs because most people just have basic web servers. If it has authentication on their application, of course, they're going to have to go back in the profile and change some stuff. But most people just have basic apps. And if it's something to do with financial, of course, they're going to have to go back on the F5. But this is just for the basic web apps that these guys throw up there for like parks or water, that this meets 80% of our needs without people having to go back in the F5 and do anything. And so if you're not familiar with this, this is Trend. And Trend does our anti-malware on our machines. And if you've ever dealt with Trend and Linux, you have to go in and manually put a client on there for anti-malware to work. And it's always a pain because all the Windows machines auto deploy in Trend and auto get inventoried. And so they work as soon as you put them on there. But Linux always gets left behind. So as part of our scripts are to get these to auto register with that agent that's on right there. And so we're showing that all 3 of them got the Trend agent on them. And so now we go back in Arkin. And this is our monitoring tool. And so now that machine exists. This is our web server. And so Arkin shows you everything that your machine touches. So you can see there's storage there, their firewalls. This is our path to the internet for that one VM. It shows you what firewalls it goes through. It shows you the NSX segment it goes through. It shows you the distributed router you go through. Shows you a transport network. Then it shows you, that's when it's leaving the enclosure, the last blade it touches, and then now it goes to the Palo Alto physical switch, and then it goes to our VRF on the 7K. So it shows you every step of the way, and if something's broken that step, you'll see it right here. If it can't communicate, it will tell you where your problem is. And that's on any VM you have. It's really nice. So this also shows you that's our 2 enclosures. This is our Brocade fabric right there I'm pointing at right now. And now this is the firewall. Every rule that applies to this VM is right there in front of you right now, just by clicking on your firewall. So you don't have to wonder, did I put in that group or why isn't it working? You can just go through and see what groups it's in. And once you start knowing your firewall rules in a glance, you'll know if your stuff's in the right, if they're in the right sets or not. And so it shows you some other things, recent problems. Whenever you first make a machine, there's always recent problems, but it shows you all the changes. So this is really easy troubleshooting on VMs. And so now we're going to show you, I'm on the app server. And what am I showing here? Oh no, I'm on the web server. So I showed I can ping the app server. And now I'm going to try to ping the DB server, and it's going to fail because what I showed you before, we don't let it jump. You can only go one hop at a time. And so, where am I at now? Big test. And so here at the web, I must have put this in here twice. Oh no, I'm showing that you could do it by IP. That's, everything else was by name before, and I wanted to show you that that we have both reverse lookup and regular working with Linux in a Microsoft environment without any interaction. And so now we're going to go, once this is done, we're going to go in and we're going to delete these. I'm going to show that everything backs out because we're still waiting for that SQL server to load because it takes a good 25 to 30 minutes to load a SQL unintended. So all this other stuff we're doing, why that's still going on. So our 3-tiered, first I'm going to show you some other stuff. I want to show you this, how easy from this portal if you need to change resources, like say you need a couple hundred more gigs on a server. We're going to go into this one server, we're going to add 200 gigs of RAM, of memory, of storage, sorry.
Someone has to pay for that.
Yeah. And so you can change the CPU or memory, and then, or you go onto the disk you want to expand, and you just add the memory right here, and it's added on the machine now. Now you just go expand your disks, and you have your extra space. And so it does that really fast. I just want to show it doesn't take a long time for customization to take effect.
So you've got that branded, but how much of that is
See, there's the
custom code?
270. Huh?
How much of that is custom code and how much of that is just baked in?
It's hard to say because we started out with just basic, and then we started doing a little bit of custom, and then we took some of their basic ones and the basic JavaScript and made copies of it and then changed it a little bit to be our stuff. So I would say probably 50-50, maybe more.
So what he just did there for the reconfiguration, that's straight out of the box.
Yeah.
That wasn't new, but all the other things where it's going into AD and DNS and coming out, and it's doing the we did a demo of this last year with the correlation with the security groups in NSX and the dynamic address groups in Palo Alto. And at that point, we basically pre-configured them all. And so when the machine showed up with the right name, it automatically went in both places. Now, it actually will take the information that comes from the blueprint, it'll actually just go dynamically build it as it goes. So 50-50 is probably being generous to the original project. It's probably, for these specific things, it's probably more than 50%
So
customized.
you need to be familiar with API programming.
Sure.
You need to know a little Python, especially for the Palo Alto network. You need to know REST API call for F5 for this to happen. You need to know PowerShell.
Say, and I,
You need to hire ENS.
well, so,
Oh, thank you.
so actually, I think I know your demo's going here, but
I have them on pause.
so actually, you guys have already been talking about this. One of the coolest things about this project is that when they reach out to F5, the people at F5 that do this stuff are the guys like, oh, wait a minute, you're going to show me some love? You're actually interested in doing this? So what happens is they get on a WebEx to do 3 things, and while everyone's in the room, hey, can you do this? Hey, can you do this? Oh, that's cool. And it just keeps going. Same thing happened when they're talking to the
Palo
Palo
Alto.
Alto guy.
That's why earlier I wanted to show who our partners
Yeah,
were,
absolutely.
because they were really partners.
I,
Palo Alto, F5, VMware, they worked with us on this because this is stuff that not a lot of people are doing, and their people want to do this,
Yeah.
but they don't have people to do it with.
say
So they're happy to do it with you.
The Palo Alto guy, I think that we're on the phone with the guy in charge of creating the APIs at Palo Alto. And so he's like, well, go to my GitHub and take a look at this. And then we say something, and he, does something, you hear the keyboard for a few minutes. He says, okay, now go back and download the raw again. And then a little bit more, he says, okay, now when you get back in there tonight, go check. And just listen to the guy on the phone. He was so excited that somebody actually cared about what he was doing and was going to use it. It was incredible. So I think a certain amount of that's just the dynamic of the partners at every level were so taken with the fact that somebody really wanted to do it, and let them do it the way that made the best sense for their particular product. Not just try to, well, we want it to happen like this. It's like, no, here's what we want it to do. Here's what we're trying to accomplish, and then let them work on that. And so that part, the partners were just incredible.
Yeah,
That part.
they were really good. That's why I wanted to call that out a couple times so people understand that. Because if you were just trying to figure this out without them, it probably would be a lot longer process. So I guess right here is where I'm getting ready to delete these. So you can see they're disposing of the 3 VMs, of the 3 tiers. So now I'll go back into Orchestrator. And you can see that's the third stage down. There's this, the disposing stage. And you can see that the ones that are going to get deleted right now. And so then we'll go back through all these tools and show that it cleaned up everything behind them. So all these properties that get applied to a VM, they live with the VM. So that's why when you decommission one, it can back out because it knows everything, every custom property you did to it is stored with the VM, so it backs them out. And that is really a nice thing because everybody knows they have orphan objects everywhere in their Active Directory and DNS, their firewalls, their F5s, because everyone's afraid to delete it because they don't know if it's really being used or not, even though the VM's gone.
Does that include VLAN pruning and everything?
Well, our VLANs we don't really use per se because we're using NSX. So those NSX segments are still there because other VMs are using it.
So on the switches, the physical infrastructure, once you get out, that you're going to traverse, you have to allow all of that through, or it does its own trunking on that tunnel.
So you have a transit VLAN to the switches, and then that's segmented up for all the different NSX segments to use that transit
Yeah,
network.
when you configure this environment for NSX, we need one VLAN that we use for the VLAN tunnel, the VXLAN tunnels, I should say. So once we've got that one VLAN configured on the physical network, we don't have to when we bring up a new logical switch, it just uses that same VLAN that's already there.
Through the physical network, and it uses the routers and the virtual routers and switches to do the rest of it.
Yeah, and at the point where it needs to be passed off to the physical
And
world, it gets.
Logical distributed router definitely has to have a connection into the transit network to get out, but once you set that up, then you're fine. So this shows that those 3 Linux VMs that I made are gone. There's no app, there's no DB left, and there's that web server was 99 and it's gone also. So it's out, all this stuff's out of vCenter. And then we'll go back into Panorama and show that it cleaned it up out of the dynamic groups. .55 is no longer there. And I believe this was 52. .52 is no longer there. And this one here is .53, 52 also was gone also. And so I'll go back into the F5 and we'll show that it's cleaned up in the F5. So you can see that the 99 machine's gone, the .11 address is no longer there, and the web page, of course, doesn't work. And so to delete a VM and have all that cleanup happens in less than 2 minutes. To make these Linux VMs do this end-to-end, the whole process to make a Linux VM is under 8 minutes. Microsoft's a little bit longer because Active Directory has a couple reboots. It's about 8 minutes, but the SQL Server is about 30. But that's a fully provisioned, everything ready to go machine. Arkin, when you delete a machine, it stays in there because this is a monitoring tool and it has a history to it. So it stays in there for a while, but now we're going to show that these machines are no longer replying to NS lookups. There's nothing, it's coming back with nothing because it got cleaned up out of DNS. And so that SQL Server probably should be almost done. It's turning on right now. And you can see I just got an email down there in the far corner that said your deletions are complete, the machines are gone. And so now we're going to go look on this SQL Server and show that everything got installed correctly. And you know how long it takes to, when you put in a ticket for a SQL Server, it has to bounce from the people who make the server to the DBA group. Then the people forget to put the backup client on it. It has to go back. These things jump around. So 30 minutes to provision SQL Server with all that stuff on there is pretty impressive. And so we'll bring up the Management Studio. And you can see that it has the right IP address. It's in AD. You can see it's ad.water.ca.gov. So all this stuff happened without us doing any interaction. Okay, so the database is up. The only thing we don't do is make their default database. They just have master and they can deal with it from there. But the good thing is what we're going to show right now is in security and logins, we have the main DBA's accounts already built in there with their Active Directory, and the backup agent account is all on here. And this is set up exactly how the DBAs want it. So now every time they work on a DB server, they're always identical. The DB files are where they're supposed to be, the logs are where they're supposed to be, temp DB is where it's supposed to be. It's consistency is the biggest thing about this, is it's much easier to manage your stuff when everything's consistent, and that's what this does, is when you provision, it's always the same way every time. So it's much easier to train your people. They don't have to figure things out why it's different this time. They'll always know everything's going to be the same way every time.
Go into and manage your rules. I forget which portion that was, but if you go in and change the parameters for that, is that automatically propagated to the servers within that environment?
If you change a security group you're talking about?
Yeah, whatever you're changing for compliance, so you can, and typically is security.
Yes. So all the security, they're dynamically put in that group by their names. So they'll always be with that group. So you make a change to that group, it will apply to everything immediately.
Okay. Cool. And what about moving them from data center to data center?
That's our next project, is to expand data centers. We're not quite there yet. This is just to get, we have like 30-something departments in CNRA. And so that's all different tenants. And so all these is cookie cutter between them all. And it's all unique. They can't talk to each other. But they all are the same so that we know how to work on them. It's just a lot of duplication. And so DWR is for water. DPR is for parks. So those tags, when a machine's built with those tags, it goes and finds the rules it's supposed to use, and it puts them in them groups automatically. And that's how everybody stays in the right groups and stays so they can't communicate with each other.
And as far as the multi-site stuff, NSX for vSphere, the current version 6.2, has the ability to have virtual centers at different sites, NSX managers at different sites. We configure them to be related. And when you go to create the logical switches and you go to create the distributed routers, the like, they now use what they call a universal version of it, universal, and that gets propagated to the different sites. and you can selectively get familiar with like policy-based routing. There's with the edge gateways or with the distributed logical router, there's this idea of a location ID. So we could make it so that via simple configuration, if a virtual machine was at one site, it would egress out through a default gateway that worked through the site it was on. That virtual machine gets restarted on the other side because of whatever reason you got brought over to the other side. It wouldn't be doing what, the sort of the, I don't know about easy version, but what seems to be the consistent version is sort of gone back over the link and back out its original gateway. It would actually go out over the location specific gateway. So we haven't got it implemented here, but that capability is all there in NSX.
How long does it take? Is it still the same build time?
So the building the machines wouldn't make any difference because they just get built at a single site. Migrating to the other sites, we just don't have that capability yet. VMware has that. We can do migrations from virtual centers from one site to another. We just haven't done any of that.
I was talking before the conference started, I was talking to the guy in the booth, and he was telling me it was capable of it, so I was curious about timeline.
No, it's all capable, it's just
Yeah,
getting that other
Yeah,
site.
We don't have it built or implemented to do that.
Steps, like
Yeah.
like an
Yeah.
onion, you got like all the layers together.
The other site and the bandwidth requirements you're gonna need between the sites. And the latency can't be there. That's the big thing, is the latency. Any other questions?
Say, we're overtime. This is lunch. But what was that?
So, if you have questions, Chris is going to be on the showcase floor in the next couple hours. So, if you have questions or want to see more about the demo, he'll be there.
Yeah, if there's a part of it you want to see more in depth, it'll be live. We'll just go on there and we'll do something and we can do it more in depth and you guys can see stuff that didn't make sense. Because I had to blow through that. It was hard to do when you got to go that fast.
Thank you very much.
All right.